Welcome to tonight's video, section 2.3, definition of polynomial functions and their graphs. A polynomial function, here's the general equation right here of a polynomial function. Something like 5x to the fourth plus 3x to the third plus 2x squared plus 6x minus 5. That is a polynomial function. The leading coefficient is the number that's in front. So in this case, the leading coefficient would be 5. The degree of the polynomial is the highest power of x. In this case, it would be 4. Now understand that all the powers must be non-negative integers for it to be a polynomial function, meaning they have to be positive whole numbers. So polynomial functions have smooth continuous curves, like this graph here. That is a polynomial function. Something like this, notice it's not smooth, that is not a polynomial function. So the graphs have to have smooth continuous curves. We can tell a lot about what the graph of a polynomial function is going to look like by looking at the function itself. The first thing we can determine is the end behavior of the graph. The first thing we can determine is what the end behavior by looking at and seeing what the degree is. If the degree is odd, then I know that the graph is going to fall to the left and rise to the right at the end. I don't know what it does in the middle, but I know at the end it's going to fall to the left and rise to the right. That is if the leading coefficient is positive. So something like 3x to the third plus blah, 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 plus 7. Because it's an odd degree and the leading coefficient is positive, I know the graph is going to fall to the left and rise to the right. If it's negative 3x to the third plus so on, plus 7, then I know it's going to do the opposite. It's going to rise to the left and fall to the right at the end. If the degree is even, then it's going to do the same thing in both directions. If it's positive, if it's an even, the leading coefficient is positive, like 4x to the fourth plus 3x to the third plus so on, then it's going to go up in both directions at the end. If the leading coefficient is negative, so if it was negative 4x to the fourth plus so on plus 7, then it's going to go down in both directions. So use the leading coefficient test to determine the end behavior of the graph here. We'll notice degree is 4. Leading coefficient is positive. So since the degree is even and the leading coefficient is positive, it's going to rise to the right. Actually, I should go from left to right. So it's going to rise to the left and to the right and rise to the right. So basically, it's going to go like that, up in both directions at the end. So here's a different one where it says use the leading coefficient test to determine the end behavior. Now, when there's more than one power here, notice how it's negative 4x to the third times x minus 1 squared times x plus 5. Notice these are all multiplied. To get the degree, you add the exponents. So notice it's 3, 2, and 1 here. So actually this is a degree 6. So, and since it's a negative leading coefficient, it's going to fall to the left and fall to the right. It's going to go down and down. In the next one, Notice when you add these up, 1, 1, the degree is 5. The leading coefficient is positive, so it's going to go down to the left and rise to the right. So it's going to fall to the left and rise to the right. Now, finding the zeros of polynomial functions, basically finding where is the graph going to cross the x-axis. These are also called roots or x-intercepts. Basically, where does it touch the x-axis? Well, in order to find the zeros, we have to set y equal to 0. And to solve a problem like this, we can factor. And remember, when we factor 4 terms, we group. So group the first 2 and the last 2. So you take out an x squared, and you have x plus 2. Take out a negative 4, and you have x plus 2. So then you have 0 equals x plus 2 is one of the factors. X squared minus 4 is the other. And remember, x squared minus 4 can factor to x plus 2 and x minus 2. So when I set those equal to 0, I get x plus 2 equals 0 and x minus 2 equals 0. So x equals negative 2 and positive 2. You might be asking me what happened to the other x plus 2, but since it repeated, I didn't need to do it twice. So this, if I looked at the graph of this function, it would cross the x-axis at negative 2 and positive 2. And I know since it's an odd function that it's going to go down to the left and rise to the right. I just don't know what it's going to do in between yet, but I know those two things about the function because of the leading coefficient test and because I found the zeros. So next thing, find all the zeros here. Remember, factor out what they have in common. If there's a negative in front, I'd factor out the negative 2. So I'm going to factor out a negative x squared. So it's x squared plus 4x, or sorry, minus 4x plus 4. And then I factor this, it gives me x minus 2 squared. When I set it equal to 0, negative x squared equals 0, so that means x equals 0. And x minus 2 equals 0, so x equals 2. So this graph would cross the x-axis at 0 and 2. To talk about what the graph will do at these points that we talked about out here, we talk about the concept of multiplicities of zeros. And basically what it means is that if you find a 0 and it has even multiplicity, meaning the power is 2 or 4, then the graph will touch the x-axis and turn around at that 0. If the 0 is odd multiplicity, then the graph will cross the x-axis at that point. Regardless, as it says, whether the multiplicity is even or odd, graphs tend to flatten out near zeros with multiplicity greater than 1. So here's what they mean. It says find the zeros of this function here. Well, basically to find the zeros, you set each one equal to 0. Well, negative 4 doesn't have an x, so don't worry about that. But x plus 1/2 equals 0. So x equals negative 1/2. Now the power here is to the second power, so it's said to have multiplicity of 2. Now remember back what we said here. If it's an even multiplicity, because it's to the second power, then the graph will touch the x-axis and turn around. So basically what it says, state whether the graph crosses the x-axis or touches it and turns around. Here it's going to touch the x-axis and turn around. So then the next one is x minus 5. Well, x equals 5. However, this is going to have a multiplicity of 3 because it's to the third power, which means it crosses the x-axis. Now, what that means basically is if I were to graph this function, if I were to graph it, now notice the degree here is 5, right? Because 2 plus 3 is 5. So I know it's an odd degree, but the leading coefficient is negative, which means it's going to rise to the left and fall to the right. I know that. Actually, it's going to fall a little more to the right this way. I know the zeros are at 5 and at -1/2. Now basically what this tells me here with the multiplicity of 2 is that this graph approaches -1/2, touches it, and then goes back up, and then approaches 5, but since 5 is a multiplicity of 3, it crosses through, and then it goes down like that. Now I notice I'm just roughly sketching. I don't really know exactly what it does in the middle here or here, but I know that it's going to go towards the 0, touch it, and because the multiplicity of 2 is go back up, then turn around and go through 5 because 5 has a multiplicity of 3, which means it's odd. So that's how the multiplicity helps us to graph. So basically, without plugging in any points, we've drawn a rough sketch of this graph because of the leading coefficient test and because of finding the zeros and multiplicity. All right, so that's our video for this evening. If you have any questions, please feel free to ask in class. Have a good evening.